The next known sequence is our geometric sequence. In this, the equation is definitely different, so we are going to have some multiplication in this, and that's a sequence formed by multiplying the initial term a by a common ratio, which is going to be r, that's why it's called a ratio, to the nth power of r to the n. So again, no same overall table here. I'm trying to make this consistent for you here. In our sequence, again, starting off with our initial, so there's a by itself, I'm going to multiply r each time I get the next current value in our sequence. Now, that's if we had to do it the long way. If we wanted to do it the short way, but again, remember, this is just one value in that sequence. That's it. That's all this explicit function is really good for, is just one value in the overall sequence. So let's look at example number 1. Let a equal 4 and r is equal to 3. And then we're going to find the first 5 terms of the geometric progression. I'm going to do the recurrence first again. Remember, recurrence meant that I'm using a previous answer to help me with the next answer. So you know it's going to start off with 4 because, again, we said a is starting off at 4, or is 4, excuse me. So anyway, we're going to multiply that by our common ratio, which is also stated to us by r. And that's going to be multiplied by 3 in order to get 12. Then I'm going to use that 12, multiply that by 3 to get 36. So again, I'm using the number ahead of me to help me out with the next one. 36 times 3 is 108, and 108 times 3 is 324. So again, in the recurrence, I am using the previous number to help me figure things out. And sometimes this is quicker, you know, hey, it's what it is. And again, our overall positions for our elements within our sequence. Again, using the progression or using the explicit function, I can go ahead and do the same calculation. You know, it's a little bit, might take a little bit more time, but again, I'm not using a number from previous in order to help me out. This is simple for right now, don't get me wrong, and this is why this is important. If this gets difficult to, hey, what's 324 times 3 is 672, I think? Oh, no, 972. But see, notice, it took me a while longer. It might have been easier just to do it this way. Go figure. So that's why you have 2 different ways of doing this, and frankly, personally, I like progression better because you and I are used to functions in programming. You just slam a number in there and bam, we get an answer back. So I like progression personally, but hey, either way you want to do it, it's totally up to you. For example number 2, almost like the example number 2 in the previous one, I want to try to find a, and this time r. Remember the other one was d? This one's r because we're looking for a ratio. So notice I'm already given some type of, well, sequence. I also want you to make sure one thing here. These symbols that I have in the notes here are just telling you where the heck did I get these from. So anyway, a is already given. We've already given a. We started off at 3. And then, well, r is going to take a lot more work on this. So very similar to what we did in the previous one here, I have to use division because the last time we used multiplication in order to do our, well, work. This time we're using division because that'll help us get the ratio. So how am I going to do that? I could pick any 2 numbers in here, but I picked these 2. I've picked the first one, which is 3 over 2. That's the first spot. And I divided it by 3, which is the next one right beside it. Now, after I did some crunching, 3's disappear here. It's going to be 1/2. So that's what my r is. Now, double check me. Double check me, have 3/8 over 3/4 and see how that works out. Good luck with that. Remember fractions? But anyway, all of them should end up being 1/2. And that's how we can find our ratio if we're not given it right off the bat. I almost forgot to give you the answer, which is really a of n equals 3 to 1/2 of n. Now, by the way, be careful. The power comes first, so it's going to be 1/2 times, or sorry, to the power of whatever n that is in order to get our sequence for that particular location.